Before we move on to the warm-up, going over it, let's talk about the goal for today. So we are on lesson 11, domain and range part 2. So today we'll be analyzing graphs of functions to learn about their domain and range. So when you're given a description of a function in a situation, determining a reasonable domain and range is what we will be doing. I will record just like always. I do recommend this video down here just because I know it's hard for 9th graders to understand domain and range and like how to write it. I don't think it's very hard, but granted, I have been doing it longer, so maybe I just have more practice, and there's more examples in this video if you want to check that out. Otherwise, we'll go over it today, and if you have questions, we make sure that you ask. The puzzle piece will be lesson 11, and you do have a quiz tomorrow on unit 4. It says mid-unit, but honestly, we are almost done with the unit. It's technically supposed to be 18 lessons, but I'm cutting it off after 12. So we have like 1 lesson next week, and then we're going to be focusing on our unit test, making sure we're ready for that. The dates for tests sometimes change, so just always look to the slides in Schoology for the most up-to-date information. But the date for tomorrow will not change. We are quizzing tomorrow, so just look over everything from unit 4 so far. Now, back to the warm-up, and also while we're talking about the unit 4 test, let's just look in Schoology for a little bit. I do have some study resources here toward the top, and actually one of them I need to move because it's at the bottom. But for every unit, I provide you a glossary, so that's what this is. We don't really spend time writing definitions in here. That's kind of a waste of time, but you do need to understand them. And we do spend a lot of time using the vocabulary and talking about them. But if you just need like a quick place to figure out what something is, that's all in there, and examples too. It actually has everything from units 1 through 4 in here, but I highlighted all the unit 4 stuff. So quite a bit of vocabulary. Just what's highlighted is what you need to know for this next unit test. So, sorry, it won't let me escape. All right. Other than that, we have the study guide for unit 4 / practice tests. This is the one that'll be worth 100 class points and due usually like the day before the test. So right now, unless the date of the test changes, right now it is due Wednesday next week. And it's made to look just like the actual test. So if you want, and I was very honest with you the last time for unit 2 that literally all we changed were the numbers. So I had some kids that were failing ever since unit 1, or really ever since the beginning of the year. And they really studied for unit 2, used the practice test. They were, participating fully when we would go over it and stuff. And they finished the unit 2 test really fast, and now they are like at a B. So it's really possible, to get your grade up, but with it being so close to the end of the year, if you need to and you haven't retaken a test, like you have just limited opportunities to do that. But yeah, take a look. This is what your 100-point portion will look like. About 10 questions, maybe a little more. So 11 questions, and the only thing that'll really be different are the numbers. So keep that in mind. And that is available now for you. All at the top until we get to the actual week of the test next week, and then I'll move it in there. Also, I have what the constructed response test will look like. So that's a new thing. We've not been able to provide those before. It was more just like knowing how to answer a short answer question. Now you can have examples so that you can prepare for that 50-point portion too. It's taking a while to load. But once you click in there, there's a link and you can see what it'll look like. So here we are. I plan to give it out tomorrow, like a paper copy, but like as a practice test, like study guide, but some stuff we haven't learned yet because it's lesson 12. So I might just hold off on that. But there's basically what it'll look like, just different numbers used. So questions on anything? All right, so back to the lesson today, lesson 11. So I'll take volunteers this time. Someone let me know a reason why A does not belong. And it could be something you said or something that you've heard in your group. Brian? It's the only one constantly. Because do the others have areas where it's decreasing? Which one? D, but it's not decreasing the whole time. But like if you're looking from maybe this point to that point, it's decreasing. So A is the only one constantly. Anyone want to add anything to that? All right. Usually there's tons of reasons, but I think in this one there's fewer reasons why it doesn't belong. Now someone different, give me a reason why B doesn't belong. Jalen? It has multiple, we'll say segments. But yeah, they do have multiple line segments in there. Anyone have a different reason why it doesn't belong? Landon? Only one with dots. So good. It has, I'll put open and closed circles. Anything else, class? All right, now someone different from those three people. Give me a reason why C doesn't belong. Brianna? It is, I'll put a constant output because technically A is also a constant rate. It's just a decreasing rate. This one has the same output for every input. So yeah, it's whatever value that is, it's the same throughout. Any other reasons? I think that one's about it. And then lastly, someone different than those people, why does D not belong? So it's the only one that goes up and down. It increases and decreases multiple times. The others either stay the same, they either go one direction. But D is the only one that goes up and down. So good. I'm glad that we can describe the graphs. We've been focusing a lot on attaching them to real world situations. So that's what we're going to do next. If you notice, you have the graphs also on your paper. They just now have descriptions attached to them. So as you can see, here they are, they have descriptions. So for example, that squiggly graph, the height of the swing in feet as a function of time since the child gets on the swing. So each graph represents some sort of different situation about the swing. The swing details are here. So let's look over that together so that you can kind of have a background for this activity you're about to do. So a child gets on a swing in a playground, swings for 30 seconds, then gets off the swing. Here are descriptions of 4 functions in the situation and 4 graphs representing them. So that's what's on your paper, the 4 graphs and the descriptions that go with them. The independent variable in each function is time measured in seconds. So independent variable, what axes do we label that on? The x-axis. Remember, I told you you can make an I with the x-axis and a D with the y-axis. That kind of helps you. So for all of the graphs on your paper, what will it be labeled as? Well, yes, Jayla, but hold on to that 1 second. class read this part again? Like if I had to put a title here. It is the independent variable, but what is the independent variable? Time and seconds. So good. So that's gonna be for all the graphs on your paper. Time and seconds. Then you'll, when you're doing the activity, have to figure out what the y-axis will be labeled as using the description. Then you'll find the domain and range given this following information. So here's what you will refer back to if you don't know what to label your axis. So the child is given 30 seconds on the swing. While the child is on the swing, an adult pushes the swing a total of 5 times. The swing is 1.5 feet or 18 inches above the ground. The chains that hold the seats and suspend it from the top beam are 7 feet long. The highest point that the child swings up to is 4 feet above the ground. Okay, so that's just some background information. I'll do one with you together because I know my first hour had a hard time and there are a lot of advanced kids in there, so they were like really confused. So let's do a few examples together. So this one, function h. We already said the x will be labeled with what? So time in seconds. Do we know where the graph time starts at? What does it start at? 0. K and C, do we know where the graph ends at? For the x? What does it end at? So then we don't know what it ends at just from the picture. But if you go back to the description and those bullet points are also on your paper, how many seconds did they spend on the swing? 30 seconds, good. So then that means the very end right here, we know is going to be labeled with 30. All right. Dre, what will the y-axis be labeled with? So look at the sentence. Can you read the sentence for me? Yes. So what are they comparing in this graph? Right? So if we compare to what? So if we have time on here, then what should probably go on this axis? Height, good. Now Abigail G. Do we know what the unit will be for the height? Read the sentence again. So what unit will we be measuring the height in? Feet. Okay, good. All right, so question, Jay? Yes. So do we know now someone different? I'll take a volunteer this time. Do we know anything about the height of the feet from just this description? The height of the swing? Brandon? No. Can we figure it out though from the other set of descriptions here? Yes. All right, so read it. When you see what the height is, anything about the height, raise your hand. See a lot more hands if we're reading it and seeing anything about the height. Brianna, what does it tell me about the height in this situation?
The swing is 1.5 feet above ground, and the beams are 7 feet long.
Okay,
And the top is 12 feet.
okay, good. So let's go back to our graph. So we know that the swing is 1.5 feet above the ground. So with this portion of my y-axis, where it starts is what value, class? 1.5. And we're not going to use the 18 inches because we chose it in feet. So we're just going to use the 1.5 feet. Because this is how much it is off the ground. The height is how high the swing is. Now, of course, when they actually swing, the height increases, and that's why it increases and decreases, increases and decreases. What's the highest height? 4 feet. So like about here looks like the highest. That means on the y-axis here is where the 4 would be. The 7 feet for the beams wouldn't talk about the height of the swing, so we'll use that 7 for something else later. But that's how you can figure out the increments on your graph, because they're clearly not labeled. You can figure out what variables you're comparing by reading the description and knowing, well, we already said that all the x-axes will be time in seconds. And then the y must be the other thing. So the last thing we're supposed to do for each example is identify domain and range. What did we say domain is? All the what in a function? All the inputs, which are what letter? X's. And the range is all the y's. What's an easy way to remember that? Dr. XY. Did we not talk about that in here? No. Okay, well, that's an easy way to remember it. Dr. XY. That's because we've used a lot of things, words to describe the X's. We call them inputs, we call them independent variables. Now I want you to attach the word domain to that X. And if you forget which it is, domain is all the X, Dr. XY. Same for the range. We've used a bunch of different words to describe the Y's. Y's are dependent, Y's are the outputs. Now they're also the range. Okay, so when it says to define your domain and range, I'll give you like the math way that we do it, and then the more like descriptive way that we practiced yesterday. So again, we said domain is all the what? The X values. The x-axis goes from what to what? 0 to 30. Really, I was looking for left to right, but yeah, it does go from 0 to 30. Does the graph go infinitely to the left, or does it stop at a certain value? At what value on the left? 0 for the x, right? Because this is the x-axis, so look at this part. So 0. And then where does it end on the right? 30. Sometimes it goes on infinitely, and you'll know because it'll have like an arrow, and we'll talk about that when it comes. But starts at 0, ends at 30. Since we're talking about the domain, I'm going to put an X in the middle. And if you set it up like this with a smaller number on the left, bigger number on the right, you can use, usually, I would say like 90% of the time, the less than or equal to sign. Because the opening always faces the what number? Bigger number. Bigger number. Wouldn't you say that all the X's that are on this line are bigger than the 0? So if the opening should face the X between these two. But wouldn't you also say that these numbers on here are smaller than the 30? Yes, because going here, they're all smaller. This is where it ends. So that's why 30 is bigger in this relationship. And then it also actually does touch the 0 and it does touch the 30. So that's why we have the equal to part in there too. If they didn't, like if it was an open circle, we would just leave the equal to part off. But I would say like 90% of the time, that's what you do. So for every boundary, and there will never be like more than 2 usually, use an equal sign. Questions on that? Julian, what do you need? When Dre comes, oh, he's back. Yeah, go ahead. All right. So that's domain. In other words, you probably say the domain is all the numbers from 0 to 30, right? Can it be like decimals in between those? Yeah, you can have 0.5 of a second or really any fraction of a second. So that's why it's a continuous graph. Now for the range, that's my y's. The y-axis goes not left to right, but up and down. So look at your graph. Look at how far it goes up and how far it goes down. Every boundary you'll use an inequality symbol to describe that. So what's the smallest y value I have on this graph? 1.5. Leave some space. What's the greatest y value I have? And since we're talking about range, guess what letter we're going to use? Y, actually. And then what symbols would I use? Good. Use those because if you set it up like this, with the smaller on the left, bigger on the right, you're basically saying y is everything in between 1.5 and 4. Because can you also have fractions of a foot? So that's why we're going to say it's everything in between. Good, any questions? All right, so we did one really in depth from start to finish. I know some of you might still be confused, that's okay. I want you to try the next 3 best you can. Pretend like you have to turn something in. I'll give you, since there's 3 of them, and they're like a little more challenging, I'll give you 5 minutes. So let's try that. When 4, and then just listen to the question I'm asking, because it's not necessarily going to be right away what your domain is, right? So group 4, what would I label the x-axis as? Time. What's the unit going to be? Second. All right, we mentioned that earlier. It said that all the x-axes would be time in seconds since the child got on the thing. Table 5. What would, and I'll add that in here too, actually. Time in seconds since child started swinging. All right, table 5. What would we label the y-axis for this one? Height, not height. We're looking at function r, so use that real quick. So it'll be time left on the swing. And what increment are we using for that? Seconds, minutes, hours, second. And if you weren't sure, there's a few ways you could tell what to label the axis. So amount of time left on the swing as a function of time since the child gets on the swing. So it's time versus time. Sometimes that happens. Usually I say time is your input, but this time also your output. To know which one, where it says function of, so you know how it's function of x, f of x, function of whatever's after would be your input. So that's why this right here is my input. Yeah, that's fine. We could probably have more than one right way of saying time left on the list. So That's my input, function of whatever follows is my input. The other thing that we're comparing is my output, so that's why the amount of time left is my output. All right, now the time we know already, hopefully, we talked about it before. The time starts at 0 for the X and ends at what? 30. It says she was on the swing for 30 seconds. So at 0 seconds, so basically for the Y-axis up here, how much time is left on the swing if she just barely started swinging? 30 seconds, good, see? Yeah, you just have to read the description and find those little additional hints, but yeah, that's it. At 0 seconds of her being on the swing, she has 30 seconds left. Now for the domain, did it change from the last time? No, she's still 0 to 30 seconds on the swing. So my domain is all the numbers from 0 to 30, including all the decimals in between. What would my range be? I'll ask a table this time. Table 6. So 30 is my highest Y value, so I'll put that on this side. What's my lowest Y value? And since it's range, what letter should I put in the middle? Good. What symbols? Less than or equal to, and then in between these two. Good. All right, that's the range for this one. Because it also goes from 0 to 30 seconds and everything in between. And it touches the 0 over here on the Y. So there you go. Questions on this one? All right. So now next one. Function D, distance in feet of the swing from the top beam from which the swing is suspended as a function of time since the child gets on the swing. So then table 7, what goes on the bottom here for the X? Yep, time, what unit? Good. How long does she spend on the swing at most? So we're also gonna have like our highest X be the 30 seconds. Good. Table 8, what would be labeled the Y-axis?
Distance.
Distance, what's our unit going to be? Feet. And if you really want to be specific, it's distance from the top of the beam to the swing. Does that change even when she swings? No, it's always how many feet away did it say on the bullet point? 7. All right, so I know this is 7 because it said in that little paragraph that we read. And it doesn't change even when she swings, that's why it stays the same. So what's my domain for this one? Table 1?
Oh. Okay. 4 from 0 from that.
Good, it did not change. She's still there for 0 to 30 seconds. Smallest X is 0, biggest X is 30. For possibly, I can look at it. I don't remember it. You guys are only my like second algebra class of the day, so I don't have everything memorized yet. But for the range, table 2, what's my only range value? 7. So in that case, I'm not gonna have an inequality. I'm gonna write it like this. Y equals, and then it's gonna look weird, it has some fancy braces. 7. We haven't done one like that yet. But when you have the range as just one number, or maybe just whole numbers in a situation, or like a select few numbers, not like 0 to 30, you list it like this. So Y equals, and these squiggly braces basically mean all the numbers in it. Okay? So we'll get more practice with those in the next few days, but whenever you see them like that, that's like the start of your list and the end of your list. So in this one, we have just one number in our list. Our only Y value is 7 for that. Good there? Okay, so then the last one. Table 2, what goes on the x-axis? In seconds, good. Where does my x-axis start? And end at 30. Good. Table 3, what will go on the y-axis? For this. You guys.
One.
So what is time being compared to in this one? Read it. So that's what our time is down here. So what is our time being compared to? Good. So it's the number of times an adult pushes the swing. That's the other thing that's in the sentence. So number of pushes. Now, how many pushes are in the little paragraph that we read? 5, right? And if you don't believe me, let's look at it. All right, it says right here, an adult pushes the swing a total of 5 times. So that's 5 pushes. Can I have a fraction of a push? No, so that's why the graph looks like this, if you thought that was a little weird. It represents how many pushes total. So how many different segments? 6, so there is technically one down here. Now, that one is right at the 0, that was the one to get them started. So if it's time, once they started swinging, then what would we label this dot at for the Y class? And then this dot, this dot, this dot, and this dot. 5. See? Just use your logical thinking. 1, 2, 3, 4, 5. My domain for this one, Julian, did it change at all? So leave it the same. My domain is still 0 to 30 seconds and everything in between. My range though, class, anyone know how to represent that? Is it everything from 0 through 5, including decimal? So really it's good, and I'm gonna add the 0 and 2, because technically this is on the Y, so I'm just gonna add that. So I would write it like this as a list, Y equals, because it's not less than, it's not greater, it's exactly either the 0, the 1, the 2, the 3, the 4, and the 5. I do not have a decimal of a push, so I'm not gonna put 0 less than or equal to Y, 0 less than or equal to 5, because it's not everything in between. Just those numbers, and that's it. Good, any questions? All right, pull out your Chromebook and just have that ready for the practice. We're still gonna do the last activity, just give me 1 minute. So you can just have your practice open and ready. This last activity really doesn't take long at all. So a tennis ball was dropped from a certain height, it bounced several times, rolled along for a short period, and then stopped. Function h gives its height over time. You're going to find h of 0, solve for h of x equals 0, meaning like what's the x, describe the domain and describe the range. So this problem is more like what you'd see on a test. Okay, so this is great practice. The first two are review of function notation. So try this out. I'll give you 3 minutes and then we'll go over it. All right, so h of 0. What is the 0 replacing in that function notation? X. So guess what we are gonna look at? The x-axis where it is 0. So what's missing in this function notation is the output, so that's what it's solving for. What's the output when x is 0? 6. So h of 0 equals 6. When you have a graph, I like it because you can just look at the graph and read it. They're always paired, x and then y. Or if it's from an equation, you have to plug in that input into the equation. It's all for the output. So, do it. Number 2, solve h of x equals 0. What is the 0 replacing that time? The output. So look where your output is 0. So what letter is your output? What axes are for your output? So look where the y is 0. What is the x when y is 0? Good, there's a few different ones. Because it's every time it's touching the ground in here. So in that case, there will be multiple answers. So x can be 0.54, 1.48, 2.25. Let me see what the other values are if we include those. It just has it as those ones. It didn't include this one over here, even though it's also touching where y is 0. And so forth. But I would say that you could include those two if you wanted. The x of 3 and the x of about like 3.75. All right, now describe the domain of the function. What is my domain? Landon?
0 is less than or equal to 5.
Good. So 0 less than or equal to x, less than or equal to whatever this value is. I don't know, I would say like 3.75. But yeah, because it doesn't actually touch the 4 yet. The book has it more in like descriptive terms, which also means the same thing. It includes all the values between 0 and the time when the ball stopped moving. All right, now describe the range. What is the range of this? Someone different this time? Brian?
0 less than or equal to y, and less than or equal to 6.
Good. So my smallest y value is 0, my biggest one is 6. And is it everything in between?
Yeah.
Yes, all the decimals. So you use the inequalities to represent that. My book says includes all the values between 0 and 6, which is the same thing. So questions, comments, concerns? All right, continue working on your practice. Let me know if you have questions as you go.